Hi everybody, so this is going to be the video for lesson 9. Lesson 9 is about secants and tangents again, but this time we're going to be talking about the line segments instead of the angles. But just to go back and review the last question from the lesson 7 homework, a bunch of you guys asked me questions on it, so I wanted to show you in a video what the setup should have looked like. So from this picture, we know that this arc here is going to be 2x, because that angle there was x, and we know that the arc will be double that angle. And the same thing goes for y. And we had to use two formulas in this to find the missing angles. So the first one is the one from lesson 7 that says that the outside angle here is going to be equal to half of the big arc minus the small arc. And that's what we did for all of the previous examples. So you guys should be pretty good with that part by now. But you can't find both x and y when they're together in the formula like that. You need something to give you more information. So there was a rule or a formula in lesson 6 that explained how to get the other piece of this. So in lesson 6, I posted the answers to that on Google Classroom last Monday. And on page 27, I believe it was. Yeah, on page 27, it had a rule that said, in a circle, when two chords intersect, the angle formed is equal to half of the sum of the intercepted arcs. So that means that the angle in the middle of two chords, so this is two chords, that angle there is going to be equal to half of this angle, or that arc, plus this arc. So that's this formula here. And by doing that, you get this information. And then you can use these two things and use one of them, solve for x, and plug that into the other, or do a system of equations, and you'll figure out what both x and y are that way. So moving on to lesson 9, the opening exercise is basically the same thing as this. It's the same ideas. So we're going to skip that for now, and we're going to look at this new rule. So this is the secant rule, which is a rule that you'll get every time you cross two secants. So those are our two secant lines, and they meet at one point outside of the circle. So the rule for this, we're going to take the words and we're going to turn it into a formula. It says that the product of the length of one secant and its exterior secant length. Okay, so the product of those two things are going to be equal to the product of the length of the second secant. So the second secant times the outside part there. And I'm going to color code it because I like to color code things. I think it makes it a little bit easier to see all of the pieces. So the length of one secant, that's AD, that's one of our secants. And the exterior length of that same secant, so that's AB. Okay, it says the product of those two things will be equal to the product of the other two. So the length of the other secant times the length of the outside part here. And we can use that and plug in all those numbers and figure out the missing pieces. We can definitely do that. But the only problem with that is if you don't have this rule memorized, you can't just use this formula, okay? Because I can switch the letters around and it doesn't become the same thing. So this is what I do to remember it because it makes it easier so I don't have to memorize this whole thing up here, okay? And this rule I'm about to show you is going to work for all of the other ones that we do in this lesson too. So instead of memorizing multiple rules, we're just going to remember one simplified formula. And that formula is this, that we're going to take the length of one secant, that's the whole secant, times just the outside part of that secant. So I'm color coding this so that you can see what piece I'm talking about. So the whole thing, AD, times the outside part of the same one, AB, that will be equal to the whole for the other one times the outside for that same one. Okay, so whole times outside equals whole times outside for any picture that looks like this. And the short way of me memorizing that is W for whole, O for outside, W, O. So, as my students last year called it, it's the woo-woo formula. Whole times outside equals whole times outside. Fun to say, something I made up. So if you ask anybody else about it or try and Google it, you're not going to find anything. Okay, so it is my way of remembering what this big paragraph here says. So we're going to use this. And the way we're going to do that is we're going to plug in the numbers that we know. So it says that AB is 6. So AB is 6. It says that BD is 2. AC is 4. And we want to find CE, so I'll call that X. So we're going to do whole times outside equals whole times outside. So the whole thing here, AD, that whole thing is 8. And the outside of that is 6. And that's going to be equal to the whole thing for the other secant, which is 4 and X together. And for this side, that was 6 and 2 together, so we added them to get 8. So we're going to do the same thing for the other side. So we're going to do X plus 4. And I'm going to put this in parentheses because we've got a plus sign in there, and we want to make sure that we don't just multiply the next thing times just the 4 or just the X. We want to make sure we multiply the whole thing times the number. So the last part is AC, which is 4. So we'll multiply that. And now we can solve for X. So 8 times 6 is going to give us 48. And then we can distribute the 4. So we get 4x plus 16. And then if you subtract the 16 over, we're going to get 32 equals 4x. Divide by 4, 8 equals x. So that means the length of CE will be 8. So that is how we're going to do these. And we're always going to use this rule. Whole times outside equals whole times outside whenever you see two secants. So that means whenever you have a circle with 2 lines that go through and cross twice. Now the next type of rule is the secant tangent rule. So that means you're going to have one secant, which goes through twice, and one tangent, which only goes through the circle once. But that has a different rule. You know, these sentences here, this one and this, they're different, but my rule is going to be the same for both. So we're going to actually use my rule first, and then we'll compare it to what this sentence up here says. So my rule was this: whole times outside equals whole times outside. So whole times outside for, let's do the secant first. So the whole thing, that is going to be 9 and 4 together, so that is 13. Times the outside part. The outside part is 4. Make it so we can actually read it. 4, there we go. And then the other one, we're going to do whole times outside again, but the whole thing is x. And then just the outside part of this one is, from the outside of the circle to the point, that's also x. Okay, so since it's a tangent line, the whole and outside are going to be the same. Okay, I didn't explain that in so much detail before, but what I mean by the outside part, the outside is everything from the point to the circle. Okay, it's just the part of the line that is on the outside of the circle. It doesn't include anything on the inside. Okay, and then the whole thing is everything from inside the circle, that chord, plus the outside. So that's what I meant by whole and outside before. So now we have this. And if we were to solve this, we're going to get 52 equals x squared. And we can solve from there. We've done that a million times. If we put it in simplest radical form, then we're going to have 4 and 13, which is 2 square root 13 for x. But if we look at what this rule says, since we didn't read this yet, it says if a secant and a tangent are drawn to the same exterior point, the product of the length of the secant and its exterior secant length, so that is what I did before, okay, so the secant is what I did in red, times the exterior secant length is the 4, the part in blue, that is equal to the length of the tangent squared. Okay, so the length of the tangent squared. So that is this squared. So x squared. And that's exactly what we ended up doing. Okay, we did x times x. But instead of memorizing to square that piece, I did whole times outside, which gave us the exact same answer. Okay, so if you have no problem memorizing both rules, you can do it whichever way you want. I'm just used to doing it this way because I think that is less, it's a little bit less to memorize. So we're going to use that and we're going to solve this one. Okay, so you try it out first, pause the video and try it, and then I'm going to do it on here and explain it. So we've got whole times outside, and that will equal the whole times the outside again. Okay, so we're going to multiply just like we did before. So the whole secant is this whole thing. So that's x plus 7 times the outside part. The outside part is just x. And that will be equal to the whole other line. So that is x plus 3 times just the outside part, which is still x plus 3. Or you can square x plus 3 squared. And that'll give you the exact same thing. So either way, you're going to take this and the next step will be the same no matter how you did it. You're going to take this and distribute it. So we get x squared plus 7x. And then when you multiply this part out, you can either double distribute it or you can do these boxes where you do x plus 3 and x plus 3. Right? Remember doing those. This should be review from last year. But if you do that, your answer is going to be this, x squared plus 6x plus 9. And then we're going to try and solve for x. So I'm going to subtract x squared and 6x. So I'll be left with 9 on this side and positive 1x over here, and be left with positive 9 as my answer. Okay, and you can check this in the original equation and make sure it works. And it will work in this case, and it should work for most of the cases that you do. One thing to keep in mind, though, is that you can never have a negative number for your length. Okay? So if you were doing this and you got something where it said -5 here, You can't have -5 because you can't have -5 inches or -5 feet, so it doesn't work that way. So make sure that you check that in your answers. Now we're going to move on to the second half of this lesson, which the rules get a little bit different from here. This next one is when you have two tangents. Okay, if we thought about that with the whole times outside equals the whole times outside rule, that's saying that you're multiplying something times itself and it will equal something else times itself. So that means that all of those numbers are going to have to be the same. So this rule is actually a little easier to memorize. It basically is saying that if you have two tangents drawn to the same point, those two tangents will be the same length. So if you look at this picture down here, it says that this tangent is 12. That means this one is also going to be 12. Okay, so those will always be the same. The other rule that's important here is the relationship between a tangent line and a radius. So if you have a tangent line that only crosses the circle once, and you have a radius that meets at the same point, those will always be perpendicular. Okay, they're always going to make right angles. So that means that you're always going to have some relationships form because of that. Okay, so those are always going to be perpendicular. So for exercise 4, we are going to find two things. One of them is the measure of arc DE. So that is this. And then we're also going to find the area of the quadrilateral, which is everything within this. Okay. Now, just a side note with this, it does say that we're looking for the measure of arc DE, but it doesn't specify whether it's the major arc or the minor arc. So when it doesn't say, usually it's going to be the minor arc, so that's the one I'm going to show you. But if you wanted to find the other half of it, this piece over here, you would just take our answer and subtract it from 360, and then you'll be able to find everything on this outside part. Okay, because a whole circle equals 360. So let's start with finding the arc first. If we were going to find this arc here, we're going to have to know what this angle is, because this is a central angle. So that means that the central angle will be equal to the measure of the arc. And we can figure that out because we have right triangles. It's hard to see the right triangles as it is, but if we drew in a line right here, we have a right triangle on the top and on the bottom. So here is a right triangle, and we have another right triangle here. We know they're right triangles because the radius and the tangent line have to be perpendicular, which means we have 90-degree angles, which means it's a right triangle. And when we have right triangles, a whole bunch of relationships are going to be true. And we know that these two triangles are going to be congruent to each other because we have this side being congruent for both. The right angles are going to be congruent, and these sides are congruent because of this rule up here. So that means we have side, angle, side. Way back from Unit 3 when we first did triangle proofs, we know those two triangles are the same size. So that means using CPCTC, all of the angles and all the other sides will be the same. So this angle and that angle will be equal. And if we know what those angles are, we can add them together to find the measure of this entire angle. Then we can find this entire arc. So we're planning everything based on all of the stuff that we already know. So what we're going to do is, since we're trying to find this angle, which is the same as this angle here, we can use that. We can find that using trigonometry. Okay? And the reason I'm going over this example, even though it's a bit complicated, is because you're going to use trig next year in Algebra 2. So let's review how to do that. if we've got a right triangle and we're looking for one of the angles, we could either use sine, cosine, or tangent. Okay, and we remember the fractions by doing so, ka, toa. All right, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I'm going to look at the red triangle I have here. With this angle, 12 is the opposite side, and 4 is the adjacent side. Okay, this is the hypotenuse, but we don't know the measure of that one, so we're not going to include it in our fraction. So opposite and adjacent, that means we're going to use tangent. So we have tangent of the angle, which will equal the opposite side, 12, over the adjacent side, which is 4. Okay, and if you wanted to reduce that to equal 3, that works. And when we're trying to find the angle, you're going to press this second button in your calculator. You're going to do arctan. Okay, so we're going to arctan both sides. Which is going to cancel out on this side and leave us with the angle. And then when you put arctan 3 in your calculator, and your calculator needs to be in degrees for this, you're going to get 71.565 degrees. And that is just this angle, so you're going to multiply it times 2 to get both of those angles. Okay, so when you do that, let's see what we get. All right, let's see. Hold on, my calculator's being slow. We have 71.565 times 2, and that is going to be 143.13. Okay? And that's going to tell us what DBE is, because that is a central angle, so it's going to be equal to the arc. If we were going to look for the major arc, DE, so this other side, you would do 360 minus 143.13. So that's going to leave us with 216.87 degrees. Okay, so depending on what your interpretation of this arc is, it could be either this or this. If it's the minor arc, it's this one. If it's the major arc, it's that one. On any test that you would get for this, they would tell you which one you're going to get. Okay? Or it would be multiple choice and only one of those would show up. So that tells us how to find the arc here, but we still have more to this question. We also want to find the area of that four-sided shape. So the four-sided shape was this right here, and that's a kite. We don't know how to find the area of a kite, but we do know how to find the area of a triangle. Okay, and this is made up of two triangles. We've got this one here and this one here. And you can find the area of those two triangles pretty easily, because when you do the area of a triangle, it's half of the base times the height when the base and the height are perpendicular. And we know that we've got perpendicular lines here. So it's going to be half of the base, which could be 12, times the height, which is 4. Okay, and when you do that, you're going to end up getting, let's say, that's going to be half of 12, which is 6, times 4. So 24 for one of these triangles. So the whole thing is two of those triangles. So the area would be 48. Okay, so that's going to sum up pretty much every unit we've done this year. This problem took something from all of those. Okay, so it's very important that you've got an understanding of that, because that summarizes most of geometry, and about half of those things you're going to still do in Algebra 2. So it's good to make sure you still know how to do this stuff. And the last one we're going to do is exercise 5. For this one, it says that we have 3 sets of tangent lines. So all of these lines are tangent because they all cross the circle once. But if we broke this down into smaller pieces, you'd see that this and this, and if you ignore the rest of it, those are 2 tangents drawn to the same point. So that means that those are going to be equal to each other. Also, these 2 are drawn to the same point. So those are equal to each other. And this is from the rule above. These 2 are also, so those are congruent. And it tells us that AD is 4, so that means this is also 4. BF is 6, so this is also 6. And CE is 7, so this is also 7. And it's asking to find the perimeter of triangle ABC, which is this whole triangle here. So let's find the length of each side, or you can add everything all together at once, whatever you want to do. Okay, so you go ahead, pause the video and do it on your own, and then I'll put the answer up here. So I'm going to do it like this to keep it organized, to make sure I don't do anything twice or skip anything. So I'm going to do, for the perimeter of triangle ABC, I'm going to do AB plus BC plus AC. So that AB is this whole thing, which is 10. BC is this whole thing, which would be 13. And AC is this whole thing, which is 11. And then just add those together, which is going to be 34. And then the last part of that, it's asking to find the length, or it says the length of the radius is going to be 8. So let's put in that. So let's say the radius is 8. I'm going to connect O to F and say that it's 8. And it says to determine the length of BO. So that's from here to here. We want to find that. We'll call that X. So OF was the radius, that's 8. That has to be perpendicular to the tangent line. So we have a little right triangle in here. And that's useful because right triangles tell us a whole bunch of stuff. And one of the things that's true with right triangles is that when you have 2 sides, which we do, we have 6 and 8, and we're looking for the third side, then we can do my favorite thing ever, which is the Pythagorean theorem. Good old Pythag coming in to save the day. So let's see. We've got a squared plus b squared equals c squared. And the only important part of this is that c has to be the hypotenuse, which in this case is x, because that's the side that's not touching the right angle. So that is going to be here. So we can put 6 and 8 as a and b. And then we can solve. So we've got 36 plus 64 equals x squared. And we get 10 to equal x. And that is our answer. Okay, so I know there was a whole lot in this lesson, but if we take a look at the homework, we have 3 questions to start with. With these, be careful of making sure that your answers for lengths aren't negative. That's the advice that I'm going to give you for this. For all of these, you can use the formula that I was using. Okay, if you use that formula, that's great. It'll work for all of them. If you don't want to use that formula and you want to use the words that were typed in the notes, you can still do that. Just make sure that you're using the correct one. Okay, this one is secant, secant, and these 2 are secant, tangent. And then these ones down here, you have the ability to do all of them, okay? Especially this one. This one has a lot of stuff that you would use next year. So if you would like to try those, you absolutely can, and I'll help you out with them if you are working on them. But I'm not going to count that towards the homework, okay? So you only need to turn in the first page of the homework. You don't need to do the second one, okay? If you'd like to do it for practice, or if you'd like to do it, later on when you don't have any more schoolwork to do, and you want to use it to practice for Algebra 2, then you can still do it. I will help you with it, but it's not going to count for your grade, okay? So if you have any questions on anything, please let me know. And that's it for this lesson.